All right. Good afternoon, everyone. I'm Dan Powers, the Executive Director of the Society for Science and User Research Facilities. Welcome to today's roundtable discussion focused on industrial users. A brief background before we get started. SSURF is a nonprofit professional society working to promote and serve the interests of the user science community. And today we've arranged another roundtable discussion intended to be the first in a series to include several industrial users describing their work with user facilities and an audience of user facility administrators and staff and other researchers. We're really looking to help prompt a discussion about the success stories and what are the best examples of collaborations and efficient kinds of protocols, and see where this conversation goes with suggestions on what else could be perhaps prompted for additional collaborations, for other ways to be even more efficient and ultimately result in even more, think of them as robust and powerful discoveries to come out of the user facilities across the country. I'm going to step back and hand this over to our board director, Tom Fitzgibbons with Dow Chemical. And I'll be working sort of behind the scenes here. I'll look to see if you have your hand raised or if you put a comment in the chat, I can help facilitate with that. But for now, thank you, Tom. Let me hand this over to you.
Sounds great. Thanks, Dan, for having us. And thank you, everybody, for joining us this afternoon or this morning, depending on where you are geographically, for this first of hopefully several roundtable discussions between industrial users and various aspects of the user research facility infrastructure. To talk about a little bit of what we're going to do, I want to introduce some of our panelists that we have joining us today. I hope we've put together a relatively diverse group of folks with unique expertise at a number of different user research facilities. They're each going to talk a little bit, either through slides or verbally, about success stories or work that they've been doing at user research facilities. We'll then have a few questions from that we've pre-prepared, as well as opening it up for the audience members to ask any additional questions. So we're really looking forward for this being kind of an informal discussion. And then we'll have a little bit of a wrap up with opportunities and what's next. So I wanted to give a little overview of who's here today. I am Tom Fitzgibbons. I am on the SSURF Board of Directors, and I'm also a Senior R&D Leader here at Dow. I sit within the Analytical Sciences division of Core R&D, and I have a long history of working with various user facilities over my 10 years here at Dow, as well as when I was in graduate school at Penn State. Joining me today, we have Shelly Kelly, who is currently is on the leadership team of the X-ray Science Division Spectroscopy Group at the Advanced Photon Source. She's been there since 2021. She got her PhD from the University of Washington. And while also being a longtime user of the APS and a research physicist at Argonne, she spent some significant time studying catalysis systems at Honeywell UOP and served as a Senior R&D Manager in that organization before returning to the APS. So she has some unique perspectives from both sides of the fence. We have Robert Palomino, who is joining us from BASF Corporation. He sits in the materials characterization group and focuses primarily on X-ray spectroscopy and microscopy. He spent 6 years at BASF improving access to synchrotron characterization. And before that, he spent some time at the NSLS while getting his PhD at SUNY Stony Brook as well. We have Bao-Hua Ngo from Intel. He is a principal engineer at Intel with over 30 years of experience working in the semiconductor industry. Right now, he's doing a lot of work you'll hear at the APS, on particularly understanding defects in metrology, non-destructive testing, things of that nature. And then finally, we have a number of researchers joining us from Merck. We have Raul Abhadia, who's a senior scientist at Merck in the Materials and Biophysical Characterization group, focusing on small angle X-ray scattering. We have Corey Hexel, a senior scientist at Merck in the Protein Structure and Chemistry group in the Discovery Chemistry organization within Merck, focusing on cryo-electron microscopy. Corey, like Shelly, has been on both sides of the fence. Before being at Merck, he spent some time at various user research facilities in the cryo-electron microscopy space. And then finally, we have Melissa Tan, also from Merck, who's an associate principal scientist in the Analytical Research and Development Organization, supporting a lot of the pipeline development in powder X-ray diffraction. In the audience today, we have a number of folks excited to hear your questions, excited that you were able to join us today. The audience consists of folks who are industrial users of facilities. We have, as Dan mentioned, user research facility staff and leadership, and then also the user facility scientists who are also joining us. I've seen a few on the call today. So with that, I'm excited to start off by talking through some of the success stories that our various panelists may have. So I'll start by handing it off to Shelly to talk a little bit about some of the work that she's been involved with the user facilities.
Thank you, Tom. Can everybody hear me?
Yes.
Tom, can you hear me? Okay, great. Thank you. And thank Dan for organizing this roundtable. It's a pleasure to be able to speak with everyone and to share a little bit of our background and knowledge, working on, as Tom said, both sides of the fence, from an industrial user to working at a user facility. So I prepared 2 quick slides without too much information on them, I hope. Let me see if I can share my screen. They're both from just within the last year here. Share and do that and say share. Did that work? I hope.
Yep, looks good.
I think it did. Okay, so the first one is an example of measurements for Apico Pharma. This was to help them establish the sameness of a crystalline material and for a new drug reference for a drug master file that was being reviewed by the FDA. And so they really needed some Zanes measurements to determine the oxidation state of their materials. And they reached out to us through an industrial portal questionnaire that's on the APS website. And that happened like in May, and user agreements were put into place by October. Measurements were made in December, and the final report in January. So I wanted to give you guys an idea of the timeline here, which was about 7 months. So I often, being on the in the industrial user side of things, 7 months might seem like a really long time, but from a user facility side, 7 months is like a super strong victory. So as being very, very fast. So I think that might be one of the key things that we could talk about, like, how do we shorten that time scale? And then here's an example of what that sample looked like. It came as a powder material, and we pressed it into a pellet, and then the X-ray beam is about the size of those crosses on there, and that's about the size of a sample, just to give you an idea. My second example is also rather simple. Let's see if it'll go down. Yeah, this one was for curium and also a drug master file to FDA. They wanted to know about their germanium in some liquid samples this time. And so I wanted to show this just to highlight the fact that we can work with all sorts of different phases of materials. And they really wanted to know that that germanium was hydrated without any other ligands around it. And so in the bottom corner here, this is the Fourier transform, and it shows a strong signal here from the first shell of oxygen, and then there's nothing after it. And so the measurement was actually to make a measurement of nothing, which sometimes is really tricky, but we were able to do that pretty well. And in this case, from initial discussions to analysis report was 5 months. So pretty similar to the other example as well. So that's all I have to share, and I hope to answer a lot of questions and have some discussion after the rest of the panelists have a chance to introduce themselves and give their examples. Thank you. Thanks, Tom.
Excellent. Thank you, Shelly.
Welcome.
I'll now pass it to Robert Palomino from BASF. Robert, if you wanted to either share or verbally talk through some of the work you've been doing as in the materials characterization group, that would be great.
Thank you, Tom. So I will go ahead and share my screen before I start discussing this. Give me 1 second.
Looks good.
Okay. Don't know. So effectively, I've been with BASF as was in the introduction for about 6 years, and during that time, a lot of focus was put on trying to expand our access to synchrotron facilities. I just wanted to highlight, 3 of the success stories, although we have a connection to a number of different facilities, APS being one of them, where we have an agreement in place for whenever we need to use it, which is a luxury whenever a lot of these facilities to be able to have that. We don't always necessarily want to try to have an agreement written up before we're ready to do it. So having something in place that anytime we do need it, all we need to do is, submit a proposal and then request the time works out very well. But Sarek Eric, or joint between Sarek Eric and Electra, is one of the newer collaborations that we'd actually have, and this primarily focused initially for micro CT, the imaging of filters, looking at morphological causes of back pressure. This has provided us with a lot of high throughput data, as well as having low contrast resolution imaging to see phases that using lab-based micro CT has actually been quite a challenge for us. They've been very flexible with everything as far as the time it takes to be able to get in, and given the fact that they are in Italy, that we can accommodate them measuring for us or us going to do it ourselves. This actually was a really good relationship to have, especially when APS was going down, because they were a principal partnership for an innovation project that we had, that the majority of the span of the project was through the shutdown of APS. So finding something else was actually a very important thing for us. We also have Brookhaven National Lab, or NSLS2, which was important for me because that's effectively, I did all of my graduate work at Stony Brook, but the work was actually done at BNL. And for postdoc, I was also at NSLS2 as well. So this was a collaboration for X-ray spectroscopy, and between NSLS2 and Advanced Light Stores in California. This is effectively the same project. This is looking at copper ion migration, and what we end up seeing is that if we take a sample that has absolutely no exchange copper in it, and we undergo hydration or a steam treatment, we can actually see the copper oxide from outside of the zeolite go to the exchange sites, and we use a combination of ambient pressure XPS to see, because it is a large shift when you get the exchange copper at the zeolite centers, to see this happen as we go, And then we can also see how morphologically the size of the particles are actually changing. If we're getting these very small clusters or individual atoms that are going to exchange sites, we naturally would see the copper oxygen copper bond go down through this steam treatment. And so both of these assisted with this. And so this was a good opportunity for us to have these good relationships, having the flexibility, the ability of proprietary versus non-proprietary work flows. And ALS and NSLS2 were actually two facilities that I used quite often throughout graduate school and postdoc, so that existed off of previous relationships that we had. And I'll pass the presentation off to anyone else who's the rest of the team here for the roundtable.
Thanks a lot, Robert. No, it's really interesting to see the use of various facilities taking advantage of their different capabilities. I'll hand it now to Bahua from Intel to talk through a little bit about the work that he's been doing recently, as well as his success stories that he's had working with user facilities.
Thank you, Tom. Let me share my screen. Okay. Does everyone see what I have on the screen?
Yes, it looks good.
All right. So apologies if you looking a little bit different on the screen versus what I have. Let me see if we can move them over to here. It's still showing okay?
It seems to have gone to your desktop, blank desktop.
Oh,
Yeah.
okay. So let me move it back. Go to this mode. Okay. How about now?
Looks good.
Looks good. Okay.
Yes.
So I'll talk briefly. This is actually, like Tom suggested, it's a fairly recent development. So at Intel, we do process development. I'm part of the TD Foundry group. We have a urgent issue that in the manufacturing process, you are always dealing with a defect and low yield. And currently, the method predominantly uses round the wafer through to the end of the line. Then you do e-test, right? Electrical testing, find out which part is working, which part is not. Then you go through this very tedious process of destructive analysis, right? Going layer by layer, finally find out the defect. When I joined, returned to Intel back in 2022 timeframe, so I thought about the new technique that's being developed. That's about 4 or 5 years ago with the 3D light source at Paul Schreier's Institute. It's called 3D X-ray tychography or laminography that can image a reasonably large area and volume without destroying the sample with very high resolution. So that's the area we're interested. And I was fortunate enough to know a lot of people who was working in the X-ray space, get connected through actually Lawrence Berkeley Lab at the Advanced Light Source, the CXRO director, Paul, and John Bird, who is now at Argonne National Lab. So they were able to connect me with Argonne, with API, and say, hey, we actually have a facility and instrument set up exactly the same as the 3D light source people done. So what we're showing here is basically a sample we sent to Argonne, and I will speak about it. It's a pretty large, relatively speaking. It's a 50 by 50 by 20 micron size. And if you look at the total volume that was images, it's about 60,000 micrometer cube. Compared to the traditional semiconductor analysis with the TEM, you're looking at about 500 by 500 nanometers, right? About 30 nanometers thick. So this is much larger volume with about 5 nanometer voxel, and we actually achieve a resolution on the order of, I would say, 5 to 10 nanometers. That still need to be analyzed. If you look in the middle, I'm not sure I can zoom in or not. Actually, this the first image upper in the middle of the left side is actually a full 3D rendering of this volume that was imaged. Then the upper right corner is actually a XZ plane cut. You can see the upper metal, which are tens of micron size, down to the very low layer, which is metal 1, metal 0, on the order of 10 to 20 nanometer feature size. And then on the lower left, that's actually CAD database. If you trust me, those are the metal 1 structures, which is about 30 nanometer width and about somewhere typical about 20 to 100 nanometer long. And then we compare that to the slices on the XY plane with the tychography data we got from APS. It's actually, we match them very, very well. So this gives us a little bit confidence that we actually can see the features without destroying them in such a large volume. So I think the lesson learned was, it's probably the lower right, I have a paragraph saying it's really a collaborative approach with Advanced Photo Source and Argonne National Lab. The APS director and associate director was very, very involved in the early discussion, and the principal scientist, the investigator, Jeff, was also very involved and very proactive, supportive for the industrial request. Right, like I said, this request is not actually coming directly, it's through AOS connection. The lesson I think is most important is actually you need to start this early. I hate to say this, right? I started this in 2022, near the end of October, and we don't get any active data back until almost like June last year, right before APS shut down to go through the upgrade. Then the data analysis took another 8 months. So we got the earlier data analysis coming back March or April this year. So it's a pretty slow process. And but if you engage earlier, have a collaborative approach, fully utilize the National Labs facility and the expertise, because they are the X-ray imaging expert, and find a solution that can work for the current and the future industrial needs. What I see moving forward is that we will be able to actually take not the end-of-line wafers, actually took some of the inline wafers, and image them within a reasonably turnaround time so that we can identify those defect modes and feed back to the fab process. Just give you a short time. From the beginning to the end of the manufacturing on the wafer, typically it takes about 14 weeks. So that's a very long time. If we can take this inline, then you will shrink this time to maybe a week or 2 for the feedback. So that's what critical to us. That's kind of my single slide share, and I'll be happy to discuss and answer any questions. Thank you.
Thanks, Bahua.
Yep.
And then I know we have a few people here from Merck as well on our team. Rahul, Corey, and Melissa. If you want to spend a couple of minutes talking through some of the work that it's great that you are using different facilities for different aspects. It'll be great to hear from you on how you're making use of user research facilities at Merck in the pharma industry.
Thanks, Tom. Yep. This is Melissa. Oh, Corey, is that you?
Oh, no, go ahead, Melissa.
Oh, it's you.
Bahua, can you stop sharing for a second too? Sorry.
Okay, let's see. Where do I do that? I'm trying.
The top of the screen it says stop share. Whatever screen you're sharing.
My screen?
Oh yeah, where it says like view options and.
Okay, hold on.
You can click a stop share.
There should be a red button.
Here? Wow, I'm still not sure. Can somebody just take over?
No, I think you have to
stop
it.
Here, share.
No, not there.
Not there? Okay.
Dan might be able to.
Yeah, you should be able to just kick me out if you can. My window is not quite.
Let me. I think here's what I can do. I'll help with this just a moment.
Thank you.
Yeah.
Okay, I've changed the setting. I think whoever wants to go next will automatically override.
Okay.
Good, thank you.
Try that, or I will.
Yeah,
Tom,
that-
I
yeah.
don't think any of the panelists from Merck will have slides. So do you want to throw up your introductory slide again?
Yes, I can share that quick. Yeah, to give an overview of who we have here.
Thank
There we
you.
go.
But
And it'll stop me from being huge on everyone's screen, which
All right, perfect. Yeah, so we have, like I said, we have Raul, Corey, and Melissa here from Merck to talk to us a bit about how they're utilizing the user research facilities as well.
I'm not sure if it's the same for everyone else, but I do still see Baohua's
I see it
desktop,
as well.
which is very
Um,
pretty.
yes,
Let me see.
it's a
You have to
free.
click
It's
on
a
view
free.
I'm
options
gonna
to
try
see.
something about. Hold on.
Oh, yes,
click-
yes. Perfect.
Okay.
It's back to yours,
And
Tom.
I'll step back, everyone. I put Bao in the waiting room.
Oh
So
no.
he's been sent to a timeout, and I'll step over and try to help with.
Well, first of all, thank you all for inviting us to be a part of this panel. Because we don't currently have a CDA in place, the scientists at Merck will largely just provide a verbal overview of some of our interactions with the user facilities. I sit within a materials science group that's focused on small molecule analytical research at Merck. And as a result, we are very interested in synchrotron powder X-ray diffraction to help characterize our materials and corroborate some of the data that we collect in-house at Merck. And one of our principal partners has been the APS. As many of the rest of you have had to experience in the last year, we've had to pivot with the upgrades that have happened at APS. And consequently, we've built partnerships at CLS and actually other user facilities around the world that have been very productive. But I would still say the gold standard for us in terms of interactions with facilities is the mail-in service that APS provides. It's highly efficient, and I've noticed that there's been this discussion about the turnaround times for getting data can be long from the start of initiation of a partnership with a user facility, but I think the mail-in service has really nailed that down. And I would love to see that model extended across to other user facilities and potentially for the applications for the mail-in service to grow as well.
Great. Should I go next?
Yeah.
Yeah, so my name is Corey. I'm with Merck, and I specialize in cryo-EM. And so cryo-EM is a bit different than some of the other facilities that we've heard about because here at Merck, we have our own cryo-EM facility with both screening and high-end data collection machines. And so the user facilities for us really act as a way of controlling the flow. So when we're in high demand, we can use some of the user facilities for resources or when we have downtime. And so it allows us to be more dynamic in the way that we work on projects. And so that's the main benefit for us. And we have several user facilities that we use, which allows us to usually get time much quicker because we can decide where we go for data collection. Yeah, and I'll be happy to answer any questions at that part.
Great. Thanks, Corey. And Raul, do you want to give a quick update as well?
Yeah, of course, of course. Hi, everyone. My name is Rahul Upadhyay. I'm within the Analytical Research and Development organization at Merck, so same as Melissa. In this materials and biophysical group, basically we focus on biologics, drug products, and so anything that's a protein in kind of our development pipeline. And so, yeah, we're coming at it from the angle of at this from the angle of solution scattering. And so, we're basically right now using small angle X-ray scattering. We have kind of similar maybe to how Corey was describing for cryo-EM. We have some internal capabilities, right? But then also, have these partnerships with some of the synchrotron sources external. So we're still kind of, our internal capabilities relatively new, so we're still kind of in the process of figuring things out. But essentially, we see the kind of external sources being nice for, doing really low concentration measurements that you may not necessarily be able to do as well internally, and then also for kind of handling overflow. So when you have high demand. And so, yeah, so far we've had some really nice, I would say, experience as well with APS and using kind of the mail-in. And actually, I do agree, yeah, with kind of Melissa's point there, because yeah, I was sort of jotting down maybe a couple of thoughts and considerations for us in industry. And to me, it feels like, at least from my perspective, right, it feels like kind of data sharing is definitely a big thing, as well as like what information we have to or do provide, right? And then I would say the other part of this with kind of the data comes a lot of the data analysis platforms that we can do. So especially in the biologic space, when it comes to some of the modeling that you can do, etc. I know, you see a variety, some web-based apps, some that you can, some software that you can either, that you can kind of access internally. And so having something that we can actually, have some internal, that we can internalize to some extent would be, is generally helpful for us. And then I think the last thing, like everyone is kind of saying, the consideration, like legal agreement versus like a fee for service kind of arrangement. So yeah, happy to kind of give the floor to everyone here and start kind of answering some questions.
Excellent. Thank you everybody on the panel for taking some time to walk through some of the ways that you're using the various user facilities. I'm going to move more towards the Q&A section. I'm going to start with a question that I'm also going to try and move back towards the kind of room here. The first question that I want to pose to the panel, and feel free to kind of answer in any order, but kind of we talked a little bit about this, but what challenges have you faced or seen as an industrial user of the various user research facilities? I'll also mention that if questions from the audience come in, please use the chat. I know we'll be monitoring that after these first question or two. But yeah, it's just looking at what challenges folks faced or seen as an industrial
in a specific
user.
order, or
not necessarily. We can we can start off with whoever wants to take that first one.
Okay, I'll go.
Sure. Thanks, Shelly.
Sure. Okay. So one of the challenges that I've noticed being with my experience on both sides of the fence is that the scientists at the user facility are very interested in publishing and collaborating with you on a research project. And from the industrial side, they're more interested in what did we learn and how closely can we keep that a secret. So sometimes that can be a difficult path to navigate. I'll just put it that way.
Yeah, that's a really good one to talk about. Does anyone want to add on to that, or have any other thoughts around challenges?
I would just add one, right? Shelly is from the facility side, the APS or Argonne. I'm from the user side. Actually, for me, the most difficult one, in addition to what just Shelly said, is actually maneuver through the internal legal landscape. And a lot of these user facility are national lab, right, managed by DOE. And because it's a government, quote unquote, entity, for industry to work with the government, there are actually quite a little internal legal hurdle you have to go through. And so for me, I think maneuver through the internal legal team, it took the most effort as well. And also the facility themselves seem to have a specific requirement. For example, Intel has a corporate, right, NDA and all that in place with Argonne, with APS in particular. But for this particular effort I was doing, APS asked to have a separate NDA for this particular thing. That took me basically a lot more time to maneuver. So I'm not sure on the facility side what can be done, because there is already an effective umbrella, right, non-disclosure agreement. And also, I'm not really sending them any proprietary samples. It's actually a sample that's you can purchase in the marketplace. So that, from my point of view, from the industry, it was a little bit easier to get through the legal hurdle, right? Because I say, hey, you can buy one from Best Buy, for heaven's sake. I just help them, right, getting this a little bit easier. Yeah. So it's actually on the facility side, they actually ask for a specific set of collaborative non-disclosure agreement to cover this particular aspect. Yep, thank you.
To add on to that, I guess more of a challenge for me has been if the type of agreement we're getting is like in the form of an NDA. That's actually a bigger legal hurdle. But if it's just something like the proprietary user agreement, or DOE has specific agreements set aside for when you're trying to do collaboration, it actually ends up being much simpler because it's effectively from the government and you can't change the agreement. And so the legal side on our side actually just says, well, there's nothing much that we could do. You can take it or leave it, kind of a situation. And typically we would opt to take it, right? I think working with some European facilities, that isn't really there. So the legal agreement process does take a bit longer. I've seen it last quite long, depending on who we're working with. It can go back and forth for a couple of months just to get that done, even if the technical people on both sides are really just want to get this done. The legal teams on each side can draw it out. So I think when it's not in the form of established agreements for things like a proprietary user agreement, which works here if you're going to do the experiment yourself, or even in a scenario where you mail it in, because although APS has the mail-in program, a lot of the other facilities through COVID have had to kind of deal with this, right? And so they have a situation where you mail the samples in, you say what needs to get done, and they kind of give you control of the actual beamline from there if necessary, but they can run it for you. So it does ends up being a little bit easier on the legal agreement side if you go through a proprietary user agreement.
Yeah, I think you bring up a really good point, Robert, around the difference. We often, when you're writing proposals for facilities, you see the checkbox of proprietary versus non-proprietary agreement, non-proprietary work, having different agreements, user agreements for proprietary and non-proprietary. I was wondering how the various organizations have either done or have their team navigated that proprietary versus non-proprietary workflow to ensure both a successful experiment while also, making sure that you kind of protect what you want to protect or need to protect.
I mean, I guess I could comment a little bit because I brought it up, but I think for me, it ends up you have on the industry side, I think you need to have somebody that is aware of what's going on to be able to make the right calls. I think having an informed decision makes a lot more sense. There's a perception that it's quite difficult to get things done working with like these facilities, and the reality is it's not as bad as what people think that it is. It's really just if you want the ability to have proprietary work done, I'm fairly certain that at least all the facilities in the US have this proprietary user agreement that you can establish. And so you can get this done before you have a need to do it. And once it's there, some facilities will require that you fund an account previously. Other facilities will say, like, you know, when you request the time, that's when the account needs to be funded. But that process is actually much shorter than actually getting the agreement in place. So at that point, after you had a proprietary user agreement in place, the only thing you need to do is when you're having a project to determine, is it okay that this is shared with everybody? If you know how the proposal review process goes, you're aware that it's going to go to external people for non-proprietary. And so everybody's going to be able to see that. It's also using government money and funding. And so the public has the right to gain access to whatever you submit. And so that's there. But if you use the non-proprietary route and you go through that specific agreement, it is just the beamline scientists and the director of the facility plus whoever is in charge of the outreach for industrial users that actually see this, all of which are bound by the non-disclosure language that's written in the proprietary user agreement. So it's actually pretty straightforward. It's just what you feel comfortable with understanding, making sure that the people on your side understand if you do go the non-proprietary route, that you don't have these protections. You go the proprietary route, you have these protections in place.
Yeah, great.
Tom, this is
go ahead.
Dan. Could I prompt a question that Charlotte had in the chat, asking the panelists if they could comment on if they've used SPP or CRADA type agreements with facilities rather than their more standard user agreement?
I've used SPP as well.
Yeah, we did.
Again,
Yeah, we have both SPP and the CRADA agreement in the past as well.
And how did that work out? Any contextual or any comparative benefit, or just ways that you'd almost choose those instead?
For SPP, I would say if SPP, I would typically use that if we are going to have a project that we want the facility to also do analysis, do work on there for us, rather than just using the facility itself. The same thing for CRADA. I believe CRADA is more just long-term. SPP is a little bit shorter term. I try to avoid, if we're using like a government facility, I try to avoid just NDAs in general, because it does take much longer to set that work up. So I would prefer to either use one of the established forms that they have, proprietary user agreement if I'm going to be conducting the work myself, SPP if it's going to be a more short-term kind of project that we want more involvement from the people at the lab, and then the CRADA agreement if it's going to be longer.
All right, could I prompt Andrea, your hands up if you wanted to ask a question?
Hi, yeah. So I'm the proposal and publications coordinator at the user office at the Advanced Light Source. I don't deal with user agreements. I especially don't deal with proprietary user agreements. So this stuff may have already been talked about, and I don't quite understand all the language here. I'm under the impression, I've been told by the person who handles the proprietary user agreements at the Advanced Light Source, that outside of protein crystallography, which is different, at all the other ALS run beamlines and outside of the CXRO, if there's a proprietary user agreement, the beamline scientist is not allowed to run the samples and not allowed to run the experiments because of confidentiality. The user has to come themselves and do it. And a lot of times the industrial users don't have the experience at the beamline, and so they can't run the experiments. But it sounds like APS just has a mail-in program, and they can just send proprietary, industrial users can send proprietary samples, and the beamlines can run the experiments for them and send the data back. Am I understanding that correctly? Is it possible that we could actually have a different kind of user agreement where we could run proprietary experiments for industrial users? Am I understanding this correctly?
Yeah, Shelly, do you want to take that? I think I saw you light up a little bit.
Oh, hi there. So I'm actually not super familiar with the mail-in service, but I believe I believe that is correct. It's definitely true for the spectroscopy group measurements that I made. I helped a lot with with handling, designing the experiments and just like I would with any general user agreement, a group from a university that's never been to the APS comes and contacts me and says, "Hey, we want to make some measurements." I help just the same way as I would with them. It's really not any different except for the fact that you don't get to most of the time you don't get to publish, and the information just has to stay confidential. So.
Okay, so there is a different way. We could potentially run experiments for industrial proprietary users, just maybe not with our current agreement as it's set up. So. Okay, thank you. Appreciate the information.
Yeah. Oh, that's great. Going back to the question on CRADAs versus user agreements, I know historically, in my experience with the two, we would typically use a CRADA if we are, as Robert said, doing more of a longer term collaboration, particularly if we're doing development work there, where it's not necessarily there's this technique that exists at the user facility, let's go use it, but more if it's like we want to partner with the user facility to augment or develop a technique, or if we want to really help push that technology forward rather than be just a user. More of a long-term collaboration is where we've used CRADA agreements in the past. Does anyone else have Melissa, Corey, Raul, Bahua, comments on anything we've covered so far around proprietary, non-proprietary agreements, various different types of agreements beyond user agreements, or how access models to the facility?
Unfortunately, I don't have too much transparency in terms of the agreement that Merck set up with the APS, but maybe to Andrea's question, we do definitely send proprietary materials. I don't think we're using the proprietary user agreement because we aren't sending our Merck scientists to APS to set up the runs. We do also blind our samples when we send them in. 11BM doesn't require us to provide the exact chemical formula, so that's just another measure that we can take to ensure confidentiality.
Excellent.
That's also another interesting way to navigate that we've done before to navigate between proprietary and non-proprietary is while you don't have the legal protections, if you go the non-proprietary route, you can add certain internal protections by how much you disclose to make sure that you're not disclosing anything that could provide an issue for you later on. It tends to, if it was something that is highly confidential, we'd have to go with the legal protection, but it's also important just to realize, the legal protections are just recourse if something gets leaked, right? It's not like it's going to be some kind of ironclad way of preventing something from happening, right? And so it's important to just have a good relationship as well with the people that you're working with too.
Yeah, and also around that, I've seen many of the facilities that I've worked with, and we've had this conversation, is most light sources operate on 8-hour shifts where, you have an 8-hour shift, but proprietary time can work hourly. And what I've seen is to get around kind of the question that Andrea mentioned of people not being maybe trained or done the experiment before, you may write a non-proprietary non-proprietary experiment, have your scientists go there, work with the beamline scientists, learn, and then you have the ability to then say, okay, we're going to do the proprietary work now. And the beamline staff can step away. You can run it now that you've learned how to do the experiment, that you know the type of experiment you're going to do the proprietary experiment, and then contact them when that's done and have the proprietary turned off, and continue on with non-proprietary, or you've reached the end of your allotted time. I've seen that model as well, where you can kind of turn it on and off during an experiment, depending on what you need.
Yeah, I think for that, probably starting with a non-proprietary would be probably better once you get the hang of it, and then you can work through the quote unquote legal logistical nightmare, because proprietary involved, you go in there physically present, and for a lot of company, my company in particular, we actually have pretty strict limitation on where you can travel, just so you know. So that's why I think the approach I took to make this a little easier to get it started is start with a non-proprietary but more basic, fundamental science capability, technical capability. That way you get familiar with the facility, what they can do. Once you get that relationship, fundamental capabilities, technically established, then you can see, you can progress to the more proprietary type of research, because then you already kind of walk through the minefield once, so you know what to avoid and what to pay attention to. I think Tom's comment was correct. The NDAs, the CNDAs, whatever, those are just recourse, you want to try to avoid those pitfalls as much as you can, early on, especially if you're newer to this activity, working with the national lab user facilities. Majority of these user facility are publicly funded, so there will be some publicity or non-intended publication publicity that you may or may not be able to anticipate.
Thank you,
Tom, this is
Bob.
Dan.
I
Could
know
I
we're
just jump in?
getting
I
kind
want to
of
give just a
towards.
time check on everything. We got 5 minutes left, so if there was a particular either topic or question, discussion point you wanted to bring up, I know we can continue on, say informally after 2 p.m. Eastern, but I wanted to just give everyone that context. Got 5 minutes on this.
And before I want to make sure I get this out before the top of the hour, I wanted to follow up on kind of what's next. So as Dan mentioned at the beginning, SSURF, one of our missions of SSURF is to serve as kind of this hub between user facilities to advocate on their behalf, share best practices across facilities. And one of the ways we're doing that is through these roundtable discussions. I'm hoping that this is the first of several roundtable discussions as it pertains to industrial user bases. And we're looking at scheduling another roundtable later this year, probably late August, early September timeframe we're looking. But this time we would like to hear on behalf of user facility leadership, whether that's the facility leadership or the user office personnel. We'd really like to hear from you on how you've worked with industry in the past, challenges, opportunities that you see. I think there's a lot of opportunities for industrial users at these sorts of facilities. I make the comment that Dow is a big company, but we're not going to build our own synchrotron. We're not going to build our own nuclear reactor for SANS experiments. We're not going to, while we have a supercomputer, we aren't going to build an exascale supercomputer probably. That you can have those capabilities at these user research facilities that can really benefit our R&D efforts. So we're excited to, I think there's excitement from the industrial user base to work with user facilities. And from what I've seen from some of my colleagues in the user facility side, that seems to be somewhat mutual. So if you have thoughts or ideas, please feel free to reach out to myself, Dan, who again is our executive director here at SSURF. Please feel free to reach out to him or myself with any ideas or thoughts that you have. If you'd like to be part of the panel discussion from the facility leadership side, to share kind of your background and your experience of working with users or industrial users as well. We would be happy to have those conversations and invite you in to join us.
Yeah, I would just make one comment. Looks like the X-ray crystallography, right, dedicated facility or beamline for the pharmaceutical company. It's a quite successful story, let's put it this way. So I would like to see from the facility side, what other kind of dedicated beamline that can be fashioned or modeled like those, because that seemed to be very, very wrong, very, very well, let's put it this way, right? I was at Argonne just earlier this week, Monday, actually, visiting, and there was some special discussion saying the APS upgrade, for example, the crystallography guys will come up much faster than the rest of the other beamlines. I said, oh, that's interesting. So yeah, I think the facility management team, if you can shed some light on how to get those more available to a broader range of industries, that would be very, very helpful. Yeah.
Yeah.
All right. Well, if there aren't any other questions, we'd actually be ending right on time. Or as we found with many of you may know, we did a previous roundtable about 3 weeks ago on the universal proposal system, and we stayed on afterwards following the more formal closure of the discussion. So if you would like to stay on, I know myself and Tom will be here, but I'd like to thank you all for making time for this hour. And I'll follow up with a prompt when we have this recording available on our YouTube channel and our website. So you could either rewatch that, you can revisit the information in the chat, and you can share this with other colleagues as may be relevant. And please look to share with myself ideas for the next agenda for this topic on another roundtable. Definitely would like to hear and have the conversation led by user facility admins and leadership who could address some of the topics that came up today. Thank you, everyone, for your time. I really appreciate your interest, and of course, the incredible science and the brilliant research that you're doing is inspiring. I'm grateful to get to convene you all and learn a little bit about the success stories here.
Yep.
Thank you.
Thank you, everyone. We'll see you
Thank you.
hopefully very soon. Bye-bye.
Bye.
Thanks, everyone. Take care.